widely, and then let's look at the current state of RISC-V in China. Here is a timeline, a partial timeline of RISC-V. Actually, uh, the original Chinese academia, the community, the Chinese community.
We are ready to go. This will be a relaxed environment. Questions, comments, things welcome. Helpful if you introduce yourself. Let me go ahead and put your names where you can come if you want to kind of chime in with anything. I'm Callista Redmond. You may have seen me yesterday or not. CEO of RISC-V International. I'll ask our panelists to introduce themselves. There's some great speakers here today. Each of them brings a lot to the discussion. And our topic today is around collaboration. And collaboration happens in so many ways, right? I mean, we at RISC-V International encourage our community to collaborate with one another. If you've seen any of my talks, you see that I often start out with, the greatest challenges of our time and the greatest opportunities are really tackled through collaboration. None of us go it alone. And we see that and believe that, across our community and as a community. We, as a community, collaborate with other communities, right? And you, as individuals, collaborate with your peers, collaborate with other organizations, collaborate across communities as well. So collaboration is essential. Collaboration comes with challenges, right? And sometimes it's difficult to really ensure that everyone gets on the same page, that there's an environment of mutual, kind of respect, and that all voices are able to be heard. Hearing all voices is sometimes difficult. So you've got language challenges, you've got cultural challenges, you've got, kind of sometimes hierarchical like mindsets and other things that can often stand in the way of collaboration. So we're going to talk a little bit today about really kind of pulling that together. So, what about culture? What about the context that we all bring with us to collaboration? How does culture impact that? How do you navigate different cultures? Anyone can jump in and go.
I think I go ahead again with basically also listening sometimes and maybe also clarifying what you mean by certain terms. Like, something might be natural to you that you understand the word or like a way of collaborating which the other partner is not used to. So maybe there's just, you need to set up, find a common ground, okay, what is the way of communicating? What do I mean if I say this or that? To basically explain how you're usually working and find that common ground. How can we work together so that it works for both parties?
I think that the three-element framework works quite well, even with dealing with different cultures. So actually, once we have communication channels and we have common interests, so sometimes different culture is not a big issue. Since we can just put aside difference and just to strengthen common interests by communications. So I found this quite well, even with my daughter. So since we have kind of, I think, different ages have different kind of culture. So we broadly broader culture. So I think I always communicate with my daughter, and sometimes I even to read what she reads, and then we have I think cross the culture, native culture.
I tried listening to my daughter's music. Sometimes it only takes so much.
I think in general, I try to be as transparent as possible, and that goes to the communication side. So being precise and sharing whatever my perspectives are, that's I think the best way to move forward, because then it's trying trying to be very technical in terms of what is the end goal, and then obviously listening is part of that, and trying to figure out how the pieces fit. Pictures are great. I love pictures. So we can draw pictures and describe systems. This gives us a way to cut through some communication challenges and then be on the same page. So we can get to a mutual understanding. Whether we agree or not, that's a different conversation. Or at least where I stand and what I'm trying to accomplish. So fundamentally through this whole process, transparency, either in the environment, what I understand, what I hear, what I'm trying to accomplish. Those are all things that I try to share with colleagues and other people who are collaborating to get to that point. And if we get to that common understanding, then I think everything else works out. So the pictures are great.
So a lot of my questions here revolve around, I think, what we're all getting at, listening, catch up on their music or other tastes, draw some pictures, things like that. What are some surprises or things that you've discovered through collaboration, either about yourself and how you show up to those endeavors, or about, you know, kind of helping to guide collaboration? Like, what are some lessons and things that you've kind of found when things get challenging? You face a situation where there are competing interests, and those competing interests really are challenged to overcome that, you know, kind of roadblock. Or you notice that there's, you know, one or two or more folks that you're just not hearing from at all. You have no idea where they stand. Like, what are some of the things that like kind of surprised you, or that you kind of took away from that, learned about yourself, learned about others in the process?
So my question. Yeah, since sometimes we maybe first I still want to emphasize that common interest is really very important for collaboration. So once we have a common interest, so any obstacles can be overcome. So I have experienced long-term negotiation with a big company on collaboration, 4 months, like dozens round of negotiation. Since even their group has 6 lawyers, and you know, so once lawyers are involved, so everything becomes complicated. So but anyway, we have common interest, very strong common interest. We want to collaborate with each other on open source project. So after 4 months, we get agreement, and once we get agreement, so everyone feels very happy and very we committed to the agreement, and over the past year, so we covered very well. And I think this experience inspired me that common interest is really important. So
Pictures are nice. I'm not going to complain, but there's just a little black box. The name's kind of in it. I ask for feedback. I try to figure out where people fit, doing follow-up. But in general, for every RISC-V meeting, right, we say this is a welcoming community. It's important that everyone can communicate, and if there's disagreements, respectful. We take that to heart. I think that's part of the fun things is just knowing that we want to hear, right? And there's no bad suggestion. In general, for the people that work with me, I try to encourage that bit of confidence. So it's really the notion, and this is kind of the fun thing, you can go back and say, hey, you didn't say anything, not in an accusatory way, but what were you thinking? And then try to tease out, well, yeah, so-and-so was thinking the same thing, and they asked the same question. So hopefully you feel free to engage and incorporate your vision of questions. So it's really going through that whole process of making space for people to feel comfortable have that conversation and contribute. And I think that's kind of one of the most important things for me is that there's that flexibility and space, and people know that I support that, right? It's the engagement process which is most important. And that's starting from masters and grad students all the way up. And so then I'm trying to get people to be intentional about why they're there and what they're trying to accomplish. So then that reinforces that process. So then it becomes more kind of self-fulfilling. So that's kind of how I think.
Yeah. So actually, I think my experience is how to intentionally to introduce like industry experts to my group. So since I'm in academia, so over my group, most members of my group are students, faculty, and so 3 years ago we launched the open source project. I will introduce in my keynote later. So and the open source project called Xiangsan is quite I think currently successful and attract many industry, many companies to support this open source project. And but I found a problem that my group is most students, since they don't have the ability to deliver high quality like not products but anything high quality open source like IPs. So then those companies feel unhappy about the quality of open source projects. So and I think the problem is we cannot solve this problem by just standing in the academia side. We needed to introduce experts, senior experts from industry. So then I intentionally recruit some engineers, with like 10 years, even 15 years experience, and they come and lead the project and engineer parts, and then students focus on like architecture exploration. And currently, this new group has run for about 1.5 years. It seems quite good. So I talk to both sides like every 2 weeks and to absorb their ideas and their feelings and try to merge them together. It's challenge, but anyway, it's still I think it's become better. This is my experience.
So my experience is maybe less like directly with companies, but like just from all the PhD students I work with during my project. And we had like different levels of experience. So we have some PhDs that are very fresh, some that came fresh to our group, so they have a different background, don't know how we usually work. Some are like come from industry to do their PhD. Some are like also completely from a different part of the world. And like especially at the beginning, I tried to make sure that maybe sometimes I just went to them like individually, like, hey, how is it going? How do you feel? Is there anything that like bothers you, or like that is I don't know, that you're trying to figure out? And then like in the end, it turned out there was something I could help them with, and just connecting them to another person. And yeah, so maybe sometimes it's really also just trying to identify, or like I don't know, going there and see what is their need, what's going on.
I'm going to add a few things too. It's hard for me to just sit and be quiet and listen. So some of the things that RISC-V does with intention is we invite and engage anyone everywhere to become a member. I mean, we have individuals joining every single day. I get agreements to sign, and this means that engineering students or researchers or hobbyists, anyone can join and participate in work groups. And by virtue of engaging in those groups without barriers of whether or not you belong to a company or another type of organization, they learn from that and they can engage in that. And it's a way to kind of invite and include anyone. We also have other programs like mentorships. We have some companies and other organizations that sponsor mentorships. We sponsor mentorships. Mentorships is a different word for internship because they're not actually employees of RISC-V, but it's more like a contract. So we have mentorships, which really kind of help. And as staff and within the community, I see a lot of folks just playing the role of mentor or coach and kind of taking folks and helping cultivate leadership. And cultivating leadership and cultivating eminence or cultivating, it doesn't, you don't have to say, oh, well, I don't really want to be a people manager someday. Well, cultivating your independent eminence as a great technologist is another really strong thing that we can do for each other, right? And building the confidence in one another and doing that through intention by inviting folks, hey, submit to the call for papers. Hey, did you know there are travel scholarships, geared for kind of bringing in more diverse perspectives? Think about how these programs and engaging in the RISC-V community can help kind of build confidence, build leaders, build that technical eminence within your organizations. Like, we're here to help you be successful, and you is organizations and individuals. Just a plug for RISC-V. All right. I don't know what time is it. Oh, we have time. So I'm going to open it up for questions, comments, experiences, whatever you'd like to add. Yes.
I'll go off on a tangent. One thing.
But you have to tell everyone who you are.
I'm Alan Baum. I work for Esperanto Technologies. Oddly enough, we have an office walking distance from here, but I'm located in Mountain View, California. I'm also the ex-chair of the Architectural Compatibility Test Group. I'm vice chair of the ISA Infrastructure Horizontal Committee. I've been involved in RISC-V for several years now. One of the barriers I've found is simply that RISC-V is worldwide, and there are lots of barriers there. One is time zones. Time zones make communication really difficult. And from an American perspective, well, there's a joke I tell. Someone who speaks 3 languages is trilingual. Someone who speaks 2 languages is bilingual. Someone who speaks 1 language is American. That's a challenge. I feel very guilty that I speak pretty much 1 language, and that makes cultural assumptions. Like China, America's 3,000 miles wide, and it's a culture, and we don't really recognize other cultures, and that's a barrier. Me personally, I've experienced
Then to coordinate with the RISC-V International. So this is currently what we have done. But anyway, there's still some information that behind the RPI. So yeah, I have no idea how to eliminate all those barriers. But anyway, they will still need to do more.
More comments, questions, experiences?
Yes, Christian Favre from CA. One of the difficult points in communication, and especially written communication, is when the discussion goes on the wrong path. So how does when you need to be very diplomatic in what you say. English is not my mother tongue, obviously. So it's very difficult to make sure that you're not making the problem worse. And so that's one of the reasons why I hate those kind of communication by written in both circumstances, because if you write something, it stays forever. And it's difficult to manage that at a distance, even through video conference that can help, but really it's face-to-face, which helps to flatten everything and make it clear. So that's one of my main concerns in communication, worldwide stuff, worldwide communication.
Richard, you haven't offended me in any written conversation. I'll let you know, it's all been great on my side.
Confirmed.
I think I saw your hand.
Yeah, Thaddeus from Tinstorrent. So one of the things that I think that we all try to do is in the RISC-V community is sort of act as friends and as collaborators and everything. We try to do this. But at some point, some of these folks are going to be competitors in the market. Right? They're all going to be.
Makes it fun.
Right. So I would be interested to hear thoughts about how we balance that transition and how we maintain collaboration even though we're competitors.
I can take that one. I mean, I think that's part of the beauty of open collaboration, whether it's in software, hardware, or anywhere else, is that you get a base level set understanding of what are the pieces of the puzzle that are the base building blocks that the entire industry needs, right? And to not take that self-serving approach of like, this is something everyone needs, but wow, I'm really far ahead on it, so I'm going to keep it to myself, because that's short-term thinking, right? And if you're doing that, then like 6 other people are doing that too. And then you're going to have, you're going to slow the entire progress. But by collaborating on those shared building blocks and then understanding where is my differentiation, where am I going to compete, safeguarding that and not bringing that to the table, but saying, all right, listen, we all need these base building blocks. This is the layer that's going to commoditize or become kind of ubiquitous across all industry. Understanding where that line is and respecting that and being open and collaborative on that layer. You don't have to bring your secret stuff or your confidential proprietary stuff to the party. In fact, we really don't want it at the party, right? So understanding where's the collaboration point and what is on your company agenda and keeping that separate is something that we always deeply encourage. I do want to point out that we have one of our ambassadors over here sporting the shirt. So ambassadors is one of those programs of kind of building eminence in the community for engineers talking to engineers, and it's at sort of a strong level. We've now introduced the RISC-V Advocate program, which is more geared for university students. So if you've got any folks that you want to sort of like build towards that kind of eminence, let us know. We'll engage in those programs. So I think the other thing is, when you're dealing with your competitors, it's not personal, guys. It's just business, And I think you find so many people kind of end up migrating around in their careers, like never take it personal, right? Because one day you're competing, the next day you're colleagues and working for the same mission.
Competitor doesn't mean enemy.
Right, exactly. And that's, at some level what transcends competition, borders, cultures, other things is like, what are we doing together? Other comments, questions?
Okay, I'll have a go. So
Wait, I can turn the camera around.
That's fine. Yeah, you can if you want. Okay, I'm a quick introduction. I'm Sammy Hegab. I'm specialist in financial technology. I come from a software engineering background, and I've recently started a PhD research in financial technology, but I'm trying to do a spin on RISC-V because I'm quite passionate about the whole community. But what I found, my experience, I've been tinkering with RISC, dev boards and emulating the architecture and that kind of stuff. But I found the information was a bit fragmented. I know there's a lot of information out there, and I've recently become a member as well. But when I went, for example, I'm just sharing my experience. When I went to the university and I asked my supervisors and I said, look, hey, this is really great. I mean, the RISC-V community, have you heard about it? And they knew very little. I know in the UK, there's obviously universities that are, I've seen representatives from various universities here. But in my particular university, they're very ignorant in the whole thing. And my supervisor said, like, send me some more information about it. It sounds interesting and that kind of stuff. So I couldn't really find a module in the university that I could just, plug into. So yeah, definitely, I spoke to you, I think, on Monday, and you mentioned there's some modules and structures and that kind of stuff, and I would love to push that forward to my university in that sense. But what I would also like to see is maybe on the site, maybe it's available or not, I'm not aware, but if there was a list of issues that maybe researchers can sort of tackle, or things that other people are working on. So we could just sort of collaborate and sort of see, okay, where I can sort of plug in, and where other sort of researchers could sort of like collaborate on working and helping each other in that way. So that's one area.
Okay.
And I also wanted to ask you as well if you're aware of any sort of financial institution or anyone that's involved in the financial sector that's actually making use of RISC-V, because I think it's actually quite brilliant.
To name banks on RISC-V, I don't have that
Yeah.
top of mind just yet.
I haven't come across anyone. I've
Yeah.
spoken to a number of people.
Anyone? Questions?
The Viper Core folks are trying to target financial use cases, so you can talk to them. I think it's around somewhere. So that'd be like the first person I would talk to. In general, yes, what you said is true. I don't think there's any other way to say it. There's a bunch of information everywhere, and part of the process is getting it all coordinated in a manageable way. There's a whole bunch of different things going on. Really, the challenge is multifold in the sense that, okay, what are you interested in? Is there an HC working group, SIG, whatever that's in that space? And then you can jump in and figure out where to play. If you have no idea, then it's just a mass of everything, and so it's very difficult. So some of it is just kind of self-awareness of what your interests are. It can be tough. The other part is then navigating it. But I mean, depending on where you are, different components within RISC-V have different roadmaps, different priorities, and so there's definitely lots of things to do. It's just a matter of do they align to what you want to do. So I can't really point you to something specific, but each of the SIGs, each of the working groups has stuff and has top lists. The interesting thing maybe to do is just to get on some of the mailing lists, and then you just start to see how all things get come through, and then you can attach to something. But you have to be somewhat proactive. There's not someone running around saying, hey, do this, unless you're actually in groups. So that's a little bit harder. But from a curriculum perspective, from a module perspective, that is top of mind. At least for me to get that. And in Europe in general, we're trying to figure out how to create something that's very much specific towards both undergrad and graduate level education with RISC-V as a tool. I think fundamentally looking back, right, this is something different from the earlier comment, but in research, RISC-V is a language where we can communicate, and then we can realize those research ideas and ideally have impact because those research ideas can quickly transfer, do the tech transfer from research into industry. So that common language, I think, is very powerful. So hopefully that helps you in terms of what you're thinking about. But finance is great because it's super analytical. If you can save a penny or whatever, then you can get your results in.
Yeah, and navigating where everything is and how to get involved in so many things. It's one of our challenges and something that we're hoping to get better at. Other comments? Questions? Happy birthday, Paul. See, we got Paul team coming in now.
I would be curious. So I'm involved in a couple of different special interest groups and task groups, and I'm in North America, and it seems like a lot of the meetings of task groups are in the Americas morning and European afternoon. It seems like people in Asia usually have a tough time attending. It's usually late at night. And most of the groups I'm involved in, we just have one meeting, like a bi-weekly meeting at the same time. But I'm wondering what other task groups and SIGs do. I know the dev boards one tries to have 2 different times. But I'm wondering how other groups tackle that, because I think people that are not in European or America's time zones, like they're at a disadvantage because they never get to attend live. Or if they do, it's very late at night, right? So.
Usually, yeah, I think usually 1 a.m. before 1 a.m. is works fine for us. But sometimes after 1 a.m. it's quite tough for us. Yeah. So usually, I think if we can arrange a meeting before 1 a.m.
Are there any groups that split it up? I know
I think we have 3 very interesting speakers. We will start with Luca Benini from ETH Zurich. There he is chair of digital circuits and systems, and he's also a full professor of the University of Bologna. And I guess most of you who know him or know at least his work. And I think he will share in his talk his insights of more than 10 years of open source, RISC-V development, and yeah, I think we will learn a lot about his research areas, which are highly efficient for the computing systems, AI, smart sensing, and so on. So Luca, please.
Good morning, everybody. It's a real pleasure to be here. So today, I'm going to describe a bit the experience we had in the last 10 years around developing open source RISC-V platforms with a focus on energy efficient and scalable computing. So we know already that computing is power bound. And this is true from the cloud, where we see now machine learning training workload skyrocketing with a double exponential slope, as shown in this picture, and hitting the bound of the amount of power we can deliver in a full data center for this type of workloads. And to train a GPT-4, we need a number that I have some trouble to say what it is to eat the 25th part. So this is crazy, and what is crazy is that it's increasing very fast, 10x every 2 years. Now, it's not only the cloud, it's the edge too. And at the same time, these larger and larger models that are becoming smarter and smarter are being pulled to the edge by numerous applications where the latency and security issues that you could face when you have everything in the cloud would avoid some of the, prevent some of the applications. So again, this exponential trend is actually pushing the edge there. And there, the power envelope constraints, of course, are much tighter, are in the order of milliwatts. So we need to distill our models, but still the energy efficiency is the key. Now, as we all know, technology, even though Moore's law has been declared as dead many times, it actually keeps going and keeps scaling actually, with a lot of effort, a lot of super smart things being deployed. So while density is increasing, however, power is not scaling at the same rate. Actually, scaling is much slower. So when we have a rate of the 2x computational capability increase needed with a fixed power bound, technology gives us only 10x every 12 years. So it's really doesn't match what we need. So we need to work in order not to burn. And what is actually shown here is that necessity is a matter of invention. So this shows how people have been very inventive to play with what you can do with the architecture and the hardware on the same technology substrate. And as you can see, we have several order of magnitude of computational capabilities, as well as several order of magnitudes of energy efficiency And people have been playing this to meet their market constraints, playing with new architectures, with bit width, and so on and so forth. So I'm trying to take a principled look at this Cambrian explosion and try to see what we can play and what RISC-V has to do with it. So the way I want to work through the challenges and the opportunity is starting from the bottom, starting from the processing element, and then moving higher and higher up on the compute hierarchy. And fundamentally, there are two main things where we burn energy: compute and move data. Okay, and so, as you will see, compute is important, but move is getting more and more important. So we need to win on both the sides. So let me get started from the processing element where the compute happens. And there, let's see what is the main issue. So there we have an operand memories, registers, level 0 instruction buffers. Here, the capacity of this memory is very small. The latency of this memory is also very small, and this is typically private storage. So here the focus is, how you can do the best with this limited capacity of private storage and get your computational units as easy as possible. However, our working sets will never fit into this small memory, and then we have to go to what we call tightly coupled memory, which is on-chip memory. This is a higher density, so higher capability of storage larger data set, but also higher latency. And it is typically shared among many processing elements. So here we have to deal with two challenges: tolerating the latency to access this memory and sharing this memory very effectively without minimizing the contention and waiting. But also this memory is not sufficient, so we have to go to the third level, typically off-chip. And here we have the density. Here we can store our working set, but the latency is humongous. And we also have the bandwidth problem to get this data. And the cost to get this data from there is super large. And here we have the problem of, again, latency and bandwidth multiplied by a couple of orders of magnitude to deal with. So let's start from the bottom. So here is where RISC-V really shines. And the way we address this problem is try to simplify to the bones what is a processing element. And fundamentally, what is a processing element is some control logic to decode instructions, and then access to the memory and access to the functional units that will actually do the job. And you need to get the functional unit right, but most important, you need to get these interfaces to instruction memory and data memory right. And the key word there is latency tolerance. What does it mean? It means that this processor must be able to issue multiple requests in the memory without stalling after the first request. Is this out of order? Not necessarily. It means that as long as you can queue up several uses of the memory and use the memory for your operation a bit later, late enough to tolerate the on-chip memory latency, then you can keep your processor busy. And this is the key idea. So we need to have a very simple element that is at the same time latency tolerant and doesn't need to blow up to the complexity of an out-of-order processor. The second keyword is extensible. Domain specialization is the key game, so we want to be able to tune our instruction set after giving you a baseline. You need to tune your instruction set to your workload, to your domain, to get the best efficiency. And there is where RISC-V, with this by-construction extensibility, makes things really great. So fundamentally, we can see this is like a plethora of different domain-specific in-processor acceleration engines that can be fed thanks to this latency-tolerant memory access in a streamlined way. So where you fundamentally are working on the functional units several cycles later after you have issued the memory request. And RISC-V is perfect for playing this type of games because you can extend your instruction set and you can also work on the microarchitecture freely. So that's what we have been doing. And the key point here is that if you look at your typical, dot product operator, is the simplest atom of machine learning, if you want, then you see that the RISC-V ISA, the native, the baseline RISC-V ISA, will do this, of course, but will do this at a very limited efficiency. In fact, over these 6 instructions, the one that really manipulates the data is the only one. The others are load and store instructions and branch counter manipulation. There's nothing wrong with the RISC-V, any RISC processor will do that. So how can we, squeeze out from the instruction stream all the other yellow boxes and keep on with the green boxes? And that's where we started to scratch our head. And the key idea here is fundamentally to align from the instruction streams the load and the stores, and fundamentally create the streams into your registers, directly into your registers, of the data coming from the memory, without having to expressly load and store every cycle. This is what is called stream semantic registers. And the other thing is that since your loop is iterating over and over the same operation, you may want to buffer this operation so that you don't have to refetch this operation multiple times. And that's what we call the floating point repetition. It's basically a level 0 buffer, or the way you want it. So fundamentally, the stream semantic register means that you have an address generator that you can pre-program with the entrance of the loop, and to generate the addresses in the memory. And thanks to our latency tolerant scoreboard-based mechanism, you can stagger these loads into the memory, load and store into the memory, before the use in your floating point unit will be needed. So the address generator, the stream generation hardware will go ahead, fetch the data, and at the end, your loop gets completely squeezed to the single FMR instruction. So right now, if you can execute this loop without stalls, you get 100% utilization of your FPU, as opposed to 1/6 utilization of the FPU as in the baseline instruction set. So that's the key idea. Playing on the instruction set and also having latency tolerant cores. In this way, you can stagger the loads and get your data. And if you unroll this dependency, and your streaming register will allow you to unroll this dependency without making your code larger, you can actually keep your memory, your floating point unit fed. This is actually an example of how you can deeply modify the ISA to get this high performance. But there are also other things that you probably are easier to relate with. For example, special data types. Machine learning is all about the narrow data types today. Floating point 32, floating point 16, to bfloat, large range, and moving to 8. So also this is something for which you need an agile instruction set to be able to adapt to the new data types that are introduced deeply. And this is actually another key issue here is that you have